Our discussion today is that of ice storms. As we can see on this image, we have an extensive amount of ice that appears to be loading onto a tree limb. And what is particularly compelling about our study of ice storms and the need to understand how they form, where they occur, and how to mitigate against these ice storms involves the following points. First, ice storms are caused by an accumulation of freezing rain, and this is a very important meteorological topic that we will be discussing. It happens to be one of the most devastating of winter weather events. In particular, the devastation can halt air and ground transportation, and most importantly, it really does impede the infrastructure of a community by weighing down and snapping power lines and trees. An excellent example of this power outage and power infrastructure destruction occurred back in 1998, in which the Great Ice Storm occurred in the province of Quebec, the province of Ontario, and also upstate New York, and in an area extending into Maine. This is an example of what happened during that ice storm. The Hydro-Quebec high voltage towers in Quebec were pretty much crumpled and destroyed because of the extraordinary amount of weight of ice that occurred during this storm. And in particular, as we will see, the accumulation of ice on these towers amounted upwards of 6 inches, an incredible amount of ice loading on these towers. So therefore, it is very important for us to understand what occurs during a freezing rainstorm, and in particular, why these freezing rainstorms occur. So what is freezing rain? First of all, in order to understand what freezing rain is, we need to understand a few basic concepts. First of all, we need to define the term supercooled water. This term means quite simply that liquid water can exist at temperatures below 0 degrees Celsius. Now, an example here is that of an ice area that is actually, as we can observe here, there's freezing occurring. We see little drips that are pouring down from the underside of an ice area. Now, what is happening in this particular process is that we have effectively a melting point, that is 0 degrees Celsius. However, what is very important is, even though 0 degrees Celsius happens to be a melting point, it does not necessarily mean that ice or liquid water will freeze at that temperature. And in fact, there are a number of very important elements and conditions that must exist for liquid water to freeze. Among them being there must be some ice nuclei, hygroscopic dust particles, soot, and so forth in the atmosphere for a freezing process to occur. These nuclei tend to be most effective at producing ice at temperatures actually less than minus 10 degrees Celsius. So therefore, it's oftentimes common to see liquid water exist at temperatures somewhere between minus 1 degree Celsius and minus 10 degrees Celsius. Generally speaking, there happen to be very, very few ice nuclei in certain regions of the atmosphere that would facilitate the production of freezing. When the temperature falls below 0, we say, therefore, that the liquid water exists in a so-called supercooled environment. So we will use the term supercool to indicate the state of H2O in a liquid phase at temperatures below 0 degrees Celsius. And the following demonstration indicates very well what happens when we utilize supercooled water and pour it onto a surface. That facilitates a freezing process. And what happens during a real freezing rainstorm is that we effectively have supercooled water that will freeze upon impact with a relatively cold surface. And therein lies the problem with a destruction of major infrastructure during the course of an ice storm. So among the impacts that occur when we do have supercooled water falling down upon a surface involves, with a contact with the surface, we have effectively, as we can see in this picture from the ice storm, tremendous amounts of loading onto tree branches, and ultimately the loading gets so substantial that the branches themselves fall, and we have all kinds of blockage of major thoroughfares throughout residential areas and major highways. So also, as the freezing rain falls, the liquid water falls onto a solid surface. As we can see, car windows are completely glazed over. All elements of roof areas are completely glazed over, and there's tremendous amounts of loading, oftentimes to the extent that not only trees can be loaded down and ultimately limbs snapping, but also roofs can collapse as well. So again, this is taken out of the 1998 ice storm in January that occurred in the area of Montreal, and there was upwards of 6 inches of loading that occurred during this event.